In the space of science and immense favored experiences, the subject of what existed early on to the enormous effect has mixed discussions and captivated characters for a really long time. This giant demand doesn't simply test how we could unravel the universe. It challenges the very farthest objectives of human information. Imagine standing at the edge of existence, analyzing the immense shadowing, and considering what lay there before our universe was envisioned. The event of the Big Bang marked the start of history, space, and what we know. In any case, there was a moment sooner ahead of time. This might have at last been a state of nothingness, a quiet before the blustering gathering began. And, accepting this is true, was it? Or maybe there was something even more disturbing that existed before time itself. As we jump further into this question, science takes us on an excursion past the universe's early phase into contemplations that challenge our care. Physicist Brian Cox, known for his work on wonders of the universe, suggests that something stunning could have existed before the Big Bang. He moves us to re-examine our thinking of the certifiable world and presence. In this exploration, we'll examine the science, the theory, and the surprising insider secrets that could explain what existed before all that. We'll explore concepts like faithful improvement, quantum changes, dark energy, and even multiverses. The reach we've covered may very well stagger you, but they could also open new understandings of our position in the universe. We intend to dive deep into a world beyond imagination, science, where the dark still winds around the shadows, leaving scientists stunned and, at times, even baffled. Let's look at what existed before the Big Bang and why these hypotheses challenge everything we thought we knew. To appreciate what might have existed before the Big Bang, we first need to take a look at what the Big Bang actually was. The Big Bang, as scientists describe it, refers to the event when the universe became extraordinarily hot and dense, expanding rapidly to set off the creation of all matter, energy, and limitless forces. When we look toward the night sky, we see evidence of this hot start, with systems fanning out from a starting point. Anyway, what caused this to happen? Or was there a time before this thick, hot beginning? As suggested by the theory of cosmic inflation, there was indeed a preceding state, and it was far from void or calm. Cosmic inflation proposes that before the Big Bang, the universe was in a state that was cold, empty, and free, essentially like a legendary vacuum. In any case, the vacuum wasn't totally empty. It contained a vast amount of energy that fueled the rapid expansion of space itself. This expansion, called inflation, occurred so quickly that it nearly settled the cause of everything that would continue in a fraction of an ongoing space. It expanded at incredible rates until the expansion slowed down, and the energy converted into particles of matter and the forces we recognize as the Big Bang. But what was the nature of this energy? Why did it, seemingly from nowhere, create the universe, and why did it stop? Researchers believe that this unlimited expansion created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly with tiny bubbles forming. Each bubble represents a universe, including our own. This idea, called the inflationary multiverse, suggests that there are possibly countless Big Bangs and an infinite number of universes, our own being just one of many. This vast, mind-bending reality challenges how we could interpret the very universe itself and leaves us with a question. What else is out there? The idea of nothingness before the Big Bang is theoretical, not real, at least according to our current understanding. Even if you remove all energy, particles, and radiation from the universe, it still wouldn't be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that we've intricately woven into a masterpiece of some sort. Even in its most vacant form, whether or not we imagine stripping away these forces, leaving a dead space, the universe would still generate new kinds of energy. This fact is perplexing to scientists, as it suggests that true nothingness may be impossible within our vast understanding. Space itself has properties, rules, and constants that prevent it from being entirely empty. Imagine creating a region with nothing in it. No particles, no radiation, and negative energy, except for quantum fields and massive constants. These would still exist, suggesting that this nothingness has properties. For example, there's a concept called zero-point energy, which refers to the most impossible energy condition of quantum fields. In this state, particles can still appear and dissipate, causing a reverberation of change even in what should be empty space. This challenges our idea of a real void and suggests that yes, even before the Big Bang there was something. Experts are still grappling with this. One of the most shocking theories in current cosmology is the possibility of eternal development. If inflation could create our universe, it's conceivable that it could continue indefinitely. Brian Cox describes a truly enormous inflationary multiverse, where universes are incomprehensibly created and expanded. Imagine each Big Bang as a spark lighting another universe, while inflation occurs in various regions, creating countless other universes. This process could, in theory, happen forever. This idea of massive universes birthing others leads to a fascinating concept of a fractal universe, where each new universe may indeed create its own Big Bang. Each universe exists as a separate, independent space, unaffected by the others, considering the rapid expansion of space. For scientists, this theory is both thrilling and disturbing, as it suggests an unending multiverse with no clear beginning or end. Imagine our universe being just a speck in a colossal cosmic system, constantly evolving and continually creating new universes. And what if that is the true nature of reality? There is no before or after, but rather an eternal pattern of universes forming. The way we interpret nothingness changes when we consider quantum field theory. As shown by this theory, the universe isn't a collection of matter floating in space. Instead, it's a complex interaction of energy fields that fill the universe, working together to create everything we perceive. These fields are like invisible oceans with particles go about as waves or unsettling influences. In any event, when fields are at their least energy level, known as the vacuum state, they are still dynamic. Particles can show up and dissipate in these fields expeditiously, getting energy prior to returning it. This trademark prompts virtual particles, substances that quickly exist and then disappear, leaving just a weak memory of their presence. The prospect of virtual particles challenges the credibility of a genuine void. Envision an unfilled universe where all matter, radiation, and energy are taken out. Would you have, in fact, nothing? As per quantum field theory, you wouldn't. Even in a vacuum, fields would remain dynamic, sometimes making transient particles. This consistent improvement in the thing ought to not be anything suggests that the universe doesn't maintain our idea of vacancy. The fields and forces persist, filling the universe with private energy that forestalls outright nothing. This understanding raises a fascinating issue. Assuming fields make particles and particles make matter, could the genuine universe have emerged from this nothingness, loaded up with quantum fields? Dark energy is an odd power that currently drives the accelerated expansion of our universe. Anyway, did dark energy exist before the Big Bang? As per certain viewpoints, the way that dark energy exists today is a delayed consequence of an energy field from before our universe's development. The properties of dark energy appear to propose a giant secret power that could have existed in some form before the Big Bang. Some theories suggest that dark energy, in a much stronger state, might have controlled the inflationary stage, causing rapid expansion. The presence of dark energy suggests that whether our universe were exhausted of all matter and radiation, this power would continue to foster the outer layer of spacetime. This thought prompts a disturbing solicitation. Assuming dark energy was present before the Big Bang, might it at some point have ultimately framed the circumstances that led to the introduction of our universe? Might dark energy at some point be the calm planner of expansion, or even the genuine start of our universe? As we examine this possibility, we face the capability of dark energy as a power shaping our universe, as well as a key that could open the secrets of the multiverse itself. Another hypothesis is that cyclic cosmology offers an option in contrast to the Big Bang as a conclusive starting point. This hypothesis suggests that the universe goes through gigantic patterns of birth, death, and re-establishment. In this model, the Big Bang is not a one-time event, but may be part of an undying cycle, where universes foster decay, and then are re-established in another cycle. This hypothesis proposes that our universe might have been re-established from the leftovers of a past universe. The course of pressure and development in a cyclic example would imply that there was never a genuine start, but rather a timeless series of universes arising, making, and restoring themselves again and again. Cyclic cosmology raises significant questions. No better time than right now, as it suggests that time itself would rehash rather than continue. Assuming that this hypothesis is right, it could imply that what existed before the Big Bang was essentially one more form of the universe, one that fell solely to bring forth our current universe. For scientists, this hypothesis offers a rich response to the subject of extreme beginnings, suggesting that there is no clear beginning. The universe has always existed in some form, rising above our viewpoints of time and presence. Gravitational waves are another intriguing thought that could reveal insight into what existed before the Big Bang. These waves, discovered in 2015, are fluctuations in spacetime caused by extraordinarily massive objects, such as black holes or colliding neutron stars. These waves can travel significant distances, conveying information about the events that created them. Might gravitational waves ever provide data about the introduction of the universe? A few physicists suggest that gravitational waves coming from the time before the Big Bang might provide insight into the condition of the universe before expansion began. Gravitational waves from the early universe could leave pieces of information that could assist with understanding whether the Big Bang was truly the start or whether there were cosmic events before that we don't yet fathom. These waves could be traces abandoned by events past our normal understanding. Their presence could also indicate a more grand construction beyond the reality we are familiar with. These weak signals could open bits of information that could change our perspective. Just as we found the Big Bang's beginning, imagine if they show the remnants of a past universe or an event that occurred before the Big Bang. As scientists continue to explore the deep reaches of space, the question remains: what existed before the Big Bang? With current theories highlighting quantum mechanics, multiverses, and vast expansion, it seems we are closer than ever to uncovering the deep secrets of the universe's beginnings. While the total response remains elusive, understanding what existed before the Big Bang continues to evolve with every discovery. As we investigate these hypotheses, we can also consider how they might fit together to show the big picture, the true essence of existence itself. Yet, up to that point, we are left with a mystery driving science and venturing into obscure places far beyond what we have yet known. As we continue exploring the topic of what existed before the Big Bang, time itself becomes increasingly hard to grasp. Time as we understand it began with the Big Bang, making the concept of before it somewhat confusing. If time itself didn't exist prior to the Big Bang, might we even talk about something existing before it? Some speculations suggest that time may not have a clear starting point, and our understanding of it might be limited by the current system of physics. One of the intriguing aspects of these theories is that they open up the possibility of new laws of physics, ones that are not yet discovered or even possible within our current understanding. If the universe as we know it started with a Big Bang, and before that, there was a state of nothingness or infinite expansion, then what governs the forces and particles in that pre-Big Bang state? Might there be a hidden layer of reality that rises above existence, where the standard laws of physics break down completely? This mysterious layer would defy all that we understand about the universe, but it could hold the solutions to some of the most significant questions. Some scientists have speculated that the start of the universe may not have been a singular event, but could instead be the result of the interaction of higher dimensional forces. According to string theory, for instance, the fundamental building blocks of matter are not point-like particles but instead one-dimensional strings vibrating at various frequencies. These strings could exist in higher dimensional spaces beyond the three-dimensional space we can observe. If this theory holds any truth, our universe could be only one slice of a higher dimensional space that intersects with others, forming the multiverse. In this scenario, the Big Bang could represent the convergence of these dimensions, with a continuous pattern of universes being made and destroyed in higher dimensions. In addition, theories such as the ekpyrotic model suggest that our universe may have come about as the result of a collision between two higher dimensional branes, membranes of spacetime that exist in multiple dimensions. These collisions, if they happened, could have triggered a Big Bang-like event, starting a new cycle of expansion and contraction. Such models offer a framework for understanding the origins of the universe that doesn't rely on a traditional singular starting point, but rather presents a scenario of continual resurrection through cosmic events. This idea challenges our conventional thinking about the beginning of the universe and opens up possibilities for how it could evolve in the future.